Alrighty, last lesson before our mid-unit test. This is some more practice on systems of linear equations, practicing how to find solutions and how many solutions a system of equations could have. So can we have 1, 2, 3, 0, infinitely many? Now this is the lesson where you're going to get some answers, right? So our learning objective today is I can tell how many solutions to a system how many solutions a system has by graphing the equations, analyzing parts of the equation, and how those affect the graph. And so today is a bit of exploration, right? Seeing what we know about our equations. And so take a look at our first 17.1, right? We have a system of equations. I want you to follow each of those directions, choose two numbers that add up to 3. Pair of values, you choose the first equation, check if that's also a solution, explain and show how you know, and think about how many solutions does this system have, right? Think about what you know about equations and about solving solutions, right? If you have a system of equation, remember, if you have a graph, you have infinitely many points that are solutions to the equation. Remember, along that line, we've talked about this before. And so what does that represent, and how can you see that in this system of equation, right? How many solutions does this system have, and how do you know? And so in 17.2, you also want to further discuss that in also practicing systems of equations, how to represent each of your variables. As I talked about in the last lesson, what don't you know, right? A recreation center is offering special prices on its pool passes and gym memberships for the summer. On the first day of the offering, the family paid $96 for 4 pool passes and 2 gym memberships, right? 4 pool passes and 2 gym memberships. Later that day, an individual bought a pool pass for herself, a pool pass for her friend, and a gym membership. And she paid $72. So think about what your two equations represent and how to create both of your equations and what each of your variables represent. I'm sorry. Think about what are you missing here? What don't you know? What don't you know, and how can that shape your variables, right? I don't know the cost of the pool passes. That might be one of my variables. What else don't I know? So to create your two variables and create your two equations as a result. And how can you find the pool pass and the price of the gym membership? Solve that system algebraically. As I said before, there's multiple ways in solving it. I don't mind if you use elimination from the previous lesson, or if you use substitution or some other method from lessons beforehand. So, oops, sorry. And then in the next part, I want you to take a look at what the graph represents and how you can solve systems of equations, how you can see the system of equations graphically. Remember, we talked about how to represent your system of equation graphically and what it means to be a solution to an equation using a graph. Remember, we talked about how solutions are points along the line, and what it means to intersect those points, and what it means to have an intersection between those points. So things you want to think about as well. In 17.3, you're practicing card sorts. Taking a look at the idea is if we have infinitely many solutions, if we have one solution, or we have, or if we have no solutions, what does the graph look like? What does an algebraic representation look like? And so sort both of your graphs and your cards into whether it's no solution, one solution, or infinitely many. Last but not least, in 17.4, you want to create two equations, and you want to create a system of equations with one solution and talk about what you notice. Try to create an equation with no solutions and see what you notice, and create an equation with infinitely many. Remember, when your graphs intersect, that means that there is a solution because it intersects at that point. So talk about what are some characteristics of the graph that has no solution, what are some characteristics of the graph that has infinitely many solutions, and what do you notice? We'll talk about this more in class, but if you want to take a look at the lesson summary, As always, I suggest reading the lesson summary after you complete the lesson as a review before we get into class. So I will see you at the mid-unit assessment. If you need any assistance, make sure you reach out to me. We'll be moving forward with the rest of Unit 2 next week.